This is the video for Unit 5 review, problem number 9. All right, Andy, who is 6 feet tall, is walking away from a street light pole 30 feet high at a rate of 2 feet per second. How fast is his shadow increasing in length when Andy is 24 feet from the pole or 30 feet from the pole? So, this is really kind of like two questions in one, all right, that we want to make sure that we understand. All right, so we have this light pole, all right. Let's just say that light pole. And here is Andy who is walking away from the light pole, right? Now, so there is a certain distance that Andy is away from the light pole. I'm going to call that X. And then there is a certain length of his shadow. I'm going to call that S, right? So the light pole shines down and creates this shadow. Right now, the light pole is 30 feet tall. Andy is 6 feet tall. Those get numbers because those are not changing, right? But X is changing. So there is a dx dt, which is some positive value. But you're told that he is walking away from the light pole at 2 feet per second. So the dx dt is positive 2. All right. But what about S? Well, S is the length of his shadow. So how fast is his shadow increasing? Well, ds dt is unknown and it is positive, but it is what we want to know. All right, so we want to find what when what, right? Find blank when blank. So find ds dt when what is true? Well, when x is 24 feet or 30 feet, right? That's the second part of the question. All right, so how are x and s related? Well, if you take a look at this, we actually have a small triangle with a 6 and the s and a large triangle here, right? So these are similar triangles. So what can we say? Well, we can say that 30 is to 6, right? 30 is to 6 as what is? Well, x plus s is the whole length of that bottom side here, um, is to just s, right? So if I simplify here, 30 over 6 is 5. So now if I multiply, uh, I get 5s equals x plus s, right? And so now that is how our variables are related, right? And so I can subtract s, so I get 4s equals x, right? And now I can take the derivative, right? So what is the derivative of 4s equals x? Well, it would be 4 ds dt equals dx dt, right? And so now at this point, we plug in our known quantities. Well, what is our known quantity? Well, we know that dx dt is 2, right? So 4 ds dt equals 2, right? And so if I divide by 4, I get that ds dt is equal to 1/2, right? So half of what? Well, half of a foot per second. Now, here's the interesting thing. We said, how fast is the shadow increasing when he is 24 feet from the pole? But where did we use the 24, right? Well, we didn't use it anywhere, right? So that means the 24 is not relevant, which means the 30 is not relevant, which means dsdt is always going to be 1/2 of a foot per second. All right. Now, how fast is the tip of his shadow moving, right? So now we are saying, okay, right? How fast is this point moving along the ground, right? So really we're saying, okay, how fast is the distance that the tip of the shadow is from the light pole, right? So really we're saying, okay, what is the derivative or the rate of change of x plus s with respect to t, right? So in other words, we're just saying what is dx dt plus ds dt. And this is very simple, right? This would just be 2 plus 1/2, right? So 2.5 or 5 halves of a foot per second, right? Okay. The last one is a little bit more challenging. To follow the tip of his shadow, at what angular rate must he lift his head when his shadow is 6 feet long? All right. So here is Andy, 6 feet tall, right? He is looking down at the tip of his shadow. Okay. And so we're saying at what rate, right, as the shadow grows in length, right, at what rate must he lift his head, right? So this is the angle in question. All right. And so the angle at which he is looking at the ground is changing. So there is a d theta dt, which is some positive value that is unknown, right? We have the length of his shadow, right, which is changing, right? So we'll call that S. So then what are we trying to find? We are trying to find d theta dt when what is true? Well, when S is 6. All right, so how are theta and S related? Well, with a tangent ratio, we can say that the tangent of theta is S over 6, right? And so now we would say, okay, well, what is how do we take the derivative of this? Well, we can take the derivative in one of two ways. Okay, since we want to know d theta dt, we could take the inverse tangent and we could say that theta is the inverse tangent of s over 6, right? And so now if I take the derivative, I'm going to get just d theta dt, right? And now I have just d theta dt. All right. And so the inverse tangent, remember the derivative of the inverse tangent is 1 over 1 plus u squared. So s over 6 squared times the derivative of s over 6, which would be 1/6 times the derivative of s, which would be ds dt. So don't forget about that. All right. So now we want to plug in what we know, right? We are given find d theta dt when s is 6. So s is 6. So d theta dt is 1 over 1 plus s over 6. So that'd be 1 over, or sorry, 6 over 6, which is just 1 squared, which is just 1, times 1/6 times and then ds dt, which as we figured out in A was 1/2, right? And so we get 1 over 1 plus 1, so that's 1/2 times 1/6 times 1/2, or 1/24th. And the units here are radians per second, all right? And so that is problem number